generation students, it's a biggest advantage, like sitting back at home and attending the classes, and especially the way you arrange the classes outside this official hour. So anyone can attend from any place.
Yeah.
Yes.
Okay, now you can start, Pridita.
Okay. Okay, sir. Just 1 minute. Just let me share the screen.
Dear student, if you have any question, please you share, always.
Yes.
My students are very good.
Yes, that's true. And last time when it was there, that research design, it was truly commendable. All of them, gave such a good examples and all. And like that one thing, I just when I teach my maybe PhD students or PhD course for students for this similar type of courses, so I give their examples only. This class example only. That students of this class organized by one of my professor of my alma mater. The students were such an they are such a knowledgeable. They shared these things with me. So you can take it as an example. Okay. So Pranam, sir. Sir, is my screen visible? Anyone can confirm?
Yes, it is visible.
Visible. Okay. So if any point of time, any problem happens because of this network glitches and the weather outside is not always good, so just do let me know. I will try to solve it and try to do the needful. Okay, so we'll begin with this today, the sampling technique. Sir, should we begin? Hello? Sir, should we begin?
Yeah, sure.
Okay. So I guess the way the course has been designed, it is mainly on this the entire research methodology, all the relevant topics. So we started with this basic concepts of research methodology because I have gone through that entire the layout of the course. It was such an wisely designed, and it started with the basic concepts of research methodology through this the steps of research methodology, because conducting a research, when we conduct a research, we need to follow certain steps. And the first and foremost, I will not tell you all the steps, because I guess by now you all are well aware of these things, and you have started doing a kind of a mini project on this, so you might be knowing all these things, right? What I need to tell you that, as sir said, that this sampling technique is very important. You also have come across many other important topics so far. That is the research design, the different types of data collection method, qualitative, quantitative research methods, etc., etc. And then like when we have the objectives of our research, because there must be some clear objectives when we conduct certain research. And then when you formulate certain hypotheses based on the literature, existing literature, and then the next step, when we enter to the next step, which is that kind of collecting data on, with the help of certain questionnaire or any other data collection tools. So when we collect data, I mean, from whom we do collect data? It could be, one is we mainly deal with primary data. So the most important thing is that who would be my sample. So it is not a very random, it is not a very haphazard. Rather, I won't use this word random, because which is a very technical term here in sampling method. So it is not a very haphazard method, or haphazardly we have to select the samples. We must know why are we selecting them as a sample. Even before that, we must know which sampling method do I need to use, do I need to follow, so that we are not going to get misled by the all the available information there in the field. So we must be knowing that who will be my samples and what would be my sampling technique. then only we can collect the data exactly from those samples, what we intend to do. And then this research method, the entire research would be, rightly conducted. So today, that is an importance of discussion of today's session. So now we enter into that main concept. And as I, told all of you in the last session when we discussed this research design, that I would rather, I would rather kind of go for a much more interaction. And if in between you have some queries, you can definitely ask me. The best of my knowledge, whatever I have, I will try to answer. Otherwise, we no need to worry about, because our expert in research methodology, statistics, our research guru is there. So sir is there. So you no need to worry about anything. So let's begin. When we talk about sample, we must know that what is, known as sample, the concept of sample. Then we need to know that what is a sampling technique, right? So I guess many of you know this, what is sample, and the bigger concept in, the bigger concept is that which is known as population. So we know that concept of population, and we also know that from the population, we need to draw certain sample in order to draw certain inferences. Now the question arises that whom are we going to draw? Why? Which method we need to use and when? And what are the pros and cons of this method? And this entire session, 2 hour sessions, will include all of them. So let's begin. I would rather, because there are certain things in the slide, but I would rather ask you all to come up with your views, that what do you mean by a sample and a population? These two are the different terms. How can you distinguish between sample and the population? Any views? Anyone would like to?
Hello? Hello? Am I audible? Hello?
Yes, you are audible.
Oh, okay. Okay. So, ma'am, basically, population could be anyone who could be taken for the research study, like anyone from the whole world or the universe, we say, said, which will be suitable for our research.
Right.
But the sample will be only like those population which we actually include in our study from taking
Yes.
table for our research study, but we take a certain people only, a portion of that population, and
Right.
that portion is called as sample.
Correct. Right. So that means that now the difference is crystal clear to all of us. So we have a population, all the members, they have certain specific specification or specific criterion. Okay. So if I would like to study, just for a vague just for a kind of, just for the mere example, if I would like to study something like the attitude of people, attitude towards taking bribe of Indian, right? So what would be my population then? Anyone? What would be my population then?
Ma'am, please repeat question.
Yeah, the question is that if I want to, my research objective is that to study the attitude towards taking bribe among Indians. What would be my population here?
Indians.
All the Indian.
Yes.
So we have different parts of, different districts, states, right? But ideally, the population is that all the Indians, no matter where you do live or reside, right? And then, but then, do you think that is it possible for us to study all of them and include all of them in our research work? Do you think is that possible?
No, it's not. It's not practical even.
It's not practical. It's not possible. Why not? Why isn't it practical or possible? Ideally, we should do it.
Because it's impossible to cover every person in the population.
Right. Impossible to cover. And if you start even, first of all, it is impossible to cover every people people there in the population, included in the population. That is one. Second is that
Time and cost.
yes, time, it is going to be time consuming, and the cost associated with that we cannot bear, because every day then you have to, because few new people will born, few new like Indian will born, few will shift some other places, then whom to track, whom not to, you will be at loss as a researcher. Do you think that if we start dealing with the population, then will any one of us be able to complete our research work?
No, ma'am. Yeah.
No. So that means it is impossible. You all are right. Now that is the the advantage of taking or selecting the best representative from the population. I use the word best representative. Now you can always argue with me that who is the best representative? What do you mean by the best representative? It depends on your objective of your research work, isn't it? Am I making sense? Can you give me any example of that? What do you mean by the best? Something is best to me based on my objectives of the research work may not be best to you based on your objective of the research work, isn't it? If you don't agree with me, tell me. If you do agree with me, kindly respond.
Yes, ma'am. Yes, ma'am.
Right. Why did I say that? For example, if I want to study the impact of budget, this year budget, on global economy, right? Or do you think that if I start interviewing, even if I'm selecting some samples randomly, now I'm using this word randomly because I will also define this word randomly. Random word is not random, right? Random words has a certain definition that will come to you later on. So if I start, I guess you got the objective of my research work, that impact of budget, this financial year budget on the global economy of India. I mean, of Indian economy, not global economy of India, of Indian economy. Is this objective clear? Now, can you think that if I start interviewing, suppose I'm using this interview as a data collection, right? Now, if I start interviewing people like me who doesn't understand much, or people like any belonging to any kind of social status, or like maybe clericals, maybe a clerical staff there in an organization, will he be able to answer it properly? Do you think his response would be very effective for your research work? Hello? Hello?
No, ma'am. His answers would not be.
Shouldn't be, ideally. Why not? Because my objective is so much specific, and I have to ask this question related to this Indian economy, the impact of this budget of this financial year on Indian economy. I have to ask those experts only, right? Yes or no?
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
Experts who are there in who are the economists, I need to have their views. Whereas on the other hand, if I need to, know the the parenting style, perceived parenting style among adolescent, right? Then I can select adolescents randomly, isn't it?
Yes, ma'am.
Okay, so that means what I stated is more or less correct now. That it depends on that. Somewhere I need to choose the subjects or the sample randomly. Somewhere non-random. Somewhere based on now everything is based on the research objective that you want to achieve. Am I making sense?
Yes, ma'am.
Right. So let's go ahead. Because I just wanted to establish this viewpoint that it is not, because few people, they have a tendency to believe that random sampling or the probability sampling, they are the best one. Non-random sampling or maybe non-probability sampling are not the it's not a good choice to use in a research work. That's what I tried to establish this point. It is based on the objective that you want to study. Nothing is good or bad at a single point of time. It's based on what you intend to do. Till now, is there any question?
No, ma'am.
No. Well, let's just go ahead. This part you already mentioned, so I will not give much time into this because it's very easy to understand. So why do we need to go for sampling? Why are we not taking care of this entire population? Because sampling, it saves cost, it costs less, time is also being saved, data are acquired or gathered rather quickly, and fewer, and when we have a less, rather than studying a population, if we are studying the sample, then there would at least the quantity would be less. When we are studying this population, that quantity would be huge. Basically it is infinite, right? So the fewer mistakes are most likely, and this physical impossibility of complete enumeration. Okay, and the more detailed study can be done, because you first of all, study can be finished, the research can be finished. Otherwise, if you start doing it with the entire population, research cannot be finished. Okay, so I think this part is clear. Should I go to this the next segment?
Yes, ma'am.
Okay. So the next, now this, as I already introduced this thing with the help of an example, right? That there are two sampling categories. Okay, one is probability sampling, another is non-probability sampling. Now, the probability sampling, the basic concept of probability sampling, who can tell me? Without looking at the slide, because what is there in the slide, it is, maybe you can say something better than what is there in the slide. So don't rely on the slides much. Can you tell me what is the basic concept of probability sampling? What is the basic feature rather of probability sampling?
Ma'am, probability sampling basically talks about that everyone in the population have an equal chance to get selected as a sample. So
Very
equal probability. Yeah.
yes. So it's had a randomness in it.
Yes.
Right? So as I said, that randomness is not that much random. So I guess now you understand what I'm trying to say. I tried to say, right? It is random means it's every element, I repeat, every element in a sample has an equal chance of getting selected into this sample, right? Every element, they are randomly chosen. So from a population, suppose there are, there are 100 cardiovascular thoracic surgeon. For example, there are 100 cardiovascular thoracic surgeon, CTVS. I guess you know this particular term, cardiovascular thoracic surgeon. So those out of 100, I am choosing randomly 20 of them, right? So all the 100, I will first, number them from 1 to 100. that is the population. And then each and every doctor will be having equal opportunity to be getting selected in the sample. There won't be any biasness. I like that doctor, he is known to me, he's familiar to me, etc., etc. That will never work here if we are following this probability sampling. There are many other sampling techniques which will come under probability sampling, but more or less the one of the basic feature of probability sampling is that all the samples randomly selected from the population and has an equal chance of equal opportunity of getting included in the sample. Hence, there is no point of, the researcher whims or judgment or convenience of selecting them. Am I making sense here?
Yes, ma'am.
Okay. Just another type of sampling, which I said, that non-probabilistic sampling, and you can see that it is where there is randomness concept is not used, is not incorporated. Now here, this is also important because when we know that, as I gave you the example, that the impact of this financial year budget on the Indian economy. So now if you start randomly selecting people, and it's that, okay, or probabilistic sampling is something which, like we are taught in the class that it is more, like kind of free from biasness, etc., etc., free from convenience, researchers, whims, etc., etc. So let's go for it. And then you will be actually committing a very serious error, which is a sampling error. Because here, if you start collecting randomly data from any common person like me or other people who doesn't have much of knowledge in Indian economy, this budget, we don't, at least I don't know much about it. So you start doing this, it will be, or a very common people, then it is of no use. You will not get any good amount of, the good quality data. So in that case, you have to go for only those people who are the economists, who are budget specialists. Am I making sense? So in that case, you need to use this non-probability sampling, where the basic feature of non-probability sampling is that the random selection of the samples into the population is not allowed. You are, as a researcher, you are using your judgment, your convenience, your expertise to collect the samples from the population. Clear?
Yes, ma'am.
Okay. Now let's move on. Okay, so once this probability sampling is done, I will ask you, any one of you, to come up with the gist of what we discussed so far. So let me first complete the probability sampling method. Then I will ask any one of you or few of you to come up with the gist of what it is, so that I can understand your level of understanding. Is that okay to you, all of you? Yes? Hello?
Yes, ma'am.
Okay. So there are a few major categories as per your syllabus. I have prepared it. However, there are many others. So these are the 4 things are there in your syllabus. Hence, I will discuss this 4. However, it is not the exhaustive list. There are many others. So this is a kind of the first and foremost important, which is very widely used in a research, is simple random sampling. Then we have systematic, stratified, and cluster. This is exactly as per your syllabus. Now, this is a simple random sampling. Let me ask you all, what is your understanding of simple random sampling? Anyone?
Um, Hello.
Yes.
Ma'am, as the name itself suggests that it is
Hmm.
simple and random. So when we just, as you said that
Hmm. Yes.
we are giving them number,
I guess there is some certain problem in your network. So your voices are cracking. Hello. Anybody else can give it a try if she's facing any problem, no issues. Yes. Yes. I guess Anjali tried to say something, but then she's not able to. So anybody else can take it forward if possible. Because I want to hear from you. I don't want to tell much. Because these things we are aware of. So I will give you
ma'am,
something interesting here as well. Yeah.
am I
Yeah,
audible
go
now?
ahead. Yes, now you are
Am
audible,
I,
Anjali.
yeah. Yes, ma'am. I was saying that as you gave that example just now earlier, that if the 100 surgeons are there and we have to pick 20, so if we simply name them or just make chits of their names and pick out 20 names, so that will be a simple random sampling.
Okay, so that is a one process of, I mean, one method used in picking up those elements of the population and including in the sample. So you said that draw of a lottery because it is visible in the screen. So I'm asking that what is a simple random sampling then? That means it is a random sampling which is simple and random, rightly mentioned, and where the every individual, every element, you can more technically you can say that every element in the population has an equal chance of being selected in the sample, and then selection of one individual, I mean one sample, is no way no way dependent upon the selection of other people. So it's not that suppose you have 6 students over here. If I need to select 2 students out of 6 students, I'm not using any kind, I mean, I'm simply writing 6 of your name. This is a one method of doing this random sample, simple random sampling. I'm writing 6 of your names, A, B, C, D, E, F, A, B, C, D, E, F, right? And then folding the paper. This is known as the lottery draw, folding the slips. And in the same manner, there shouldn't be any mark like Anjali, there should be a mark of A. For somebody else, there should be a mark of something which will help me to selecting the Anjali only. It's not that thing, right? What we need to do, we can make a separate slips of papers and then put it in a box, shuffle them and pick one by one. And then I need to, so I will pick first one, maybe B is getting selected, and then the second chit. So B is included in the sample, and then second chit I will select, and that is going to be maybe E. So B and E got selected. So this is the, but then it is every element in that population is a 6 here in this particular course. All the names are there. Every individual getting selected in the sample is independent, and there should not be any kind of biasness used while drawing the samples. It is completely independent, right? And this is the one method in a lottery draw. Another method, as we all know, that's where I have something interesting to tell you. I guess you know this, but then I will tell you this so that you can use it in your research work. And that's very interesting because in our days, we used to use this, it was there, but we were not much aware of it. We used to use this, the random number table. Till that also, the researchers, they do use it, the random number table. But I would rather say that you guys will use this technique, which is very simple. Okay, so let me just go to the next thing. Yeah. So just 1 minute, I'm just stop sharing my screen And let me, all of you have internet, I guess, because you are attending classes online. So what you need to do, you need to just 1 minute. So I will send you the link, right? Or I can do one thing, I can share the screen. So give me just 1 minute. Just 1 minute. I'm not getting exactly that thing, but I got it while before this class. It was really nice. 1 minute. Meanwhile, I'm just give me just 1 minute. Meanwhile, if you have any queries or if you want to add something, you can, and you can utilize this time. I'm just searching something which is very interesting. I hope many of you know this, but I just wanted to, show you, because this is very easily you can do it with the help of this software. Yeah, I got it. Okay, so let me just share my screen here. Yeah. I guess this screen is visible. The screen is visible.
Yes, ma'am. Yes.
Okay, so I will send you, no need to worry about this, and I will send you this link. So you can do it at any point of time in your research work. So you will write down here, suppose as I said, 1 to 100. Suppose this particular doctor case, right? I guess you remember the doctor's case. So 1 to 100, 100 elements there in the population, and you have to select 20, right? So very easily, 1 is minimum, 100 is max. So you just click on generate 77. Can you see this? Hello?
Yes, ma'am. Yes, ma'am.
Yeah, I guess it is very interesting. You all like it. This is 9. You don't need to even look at your random numbers table, which is bit, I won't say it is a bit hectic, but then it's just time consuming rather than you just do it and then pick up that sheet or pick up that individual, because you have to label the individuals with this 1 to 100. Doctor number, Dr. A1, Dr. B2, this way, 100, Dr. 100 kind of. Then 77, you click on this, 51, click on this, 17, 2, etc., etc. Till the point, you will continue this till the point it is 20. So isn't it easy? Isn't it very easy?
Yes, ma'am.
Yes, ma'am.
Okay. And very interesting. So this time, when you are doing it, you will be, khushi will be doing these things. It's not that, okay, again, we have to go for this random number selection, which is very hectic, etc., like this. Okay. So I'm just sharing this link here so that you all can access this later on. No need to worry about it. And if you face any problems, do let me know. This is what the link all about. Okay. So this is very interesting anyways. So that then the random number generation has become very interesting, right? Okay, let's just close this thing and back to this sampling thing. Okay, so meanwhile, if you want to say something, you can. Otherwise, I will continue with this. Let us just continue. Can you see my screen again? I guess yes.
Yes, ma'am.
Yeah. So let us go ahead. So that means there are two methods which can be used in order to go ahead with the sampling, that simple random sampling, choosing the samples from the population, right? One is lottery, another is this very easiest and very interesting one. Okay. This I have given this thing, but then you can use that link. Okay. Now sampling with this random sampling can be of can be divided into two subdivisions. Okay. One is sampling with and without replacement. So one is sampling with replacement, another is sampling without replacement. Okay. So the thing is that this actually, it is known as SRSWOR. If you want to write down, you can write down SRSWOR. So what is SRSWOR? Simple random sampling without replacement. Okay. And SRS, one is without replacement, another is SRS, a simple random sampling with replacement. Okay. Now, what is SRS? What is simple random sampling without replacement and what is with replacement? So here it is. One is, first let me tell you without replacement, because what we generally do use in our most of our research work, we generally do use this simple random sampling without replacement. So the thing is that if you read this first paragraph, if you just read the paragraph, you can tell me what it is, if you understood it. This is about the SRS, this simple random sampling without replacement. If you read this paragraph means this one. Suppose to this, I guess you can, you can see my cursor over here. Can you tell me what it is? So when it is without replacement, what is the thing?
Suppose we have 5 chocolates.
No,
5
first
different-
just 1 minute. You first give this example, what is here only. Try to explain it with this example so that everybody can follow what is written and what is told. Am I clear?
Yes, ma'am.
Yeah, so do this, and then if you have some other example in mind, then you can tell me later on. So that first time everybody can see and hear the same thing. Yeah. Varsha?
Without replacing one is, ma'am, like in this, it is we have to choose 20 students out of 80. So on the first round means 20 times we have to do the same thing. Okay. So when the first time we chose, one was picked up. Okay. Now the leftover
The probability is 1 by 80.
1 by 80, yes.
Right. So
Means out of 80, yes, anyone can be chosen. Okay.
Right.
So
then yes, that person, suppose person B, the number 2 has been selected first time. So when 2 was selected, the probability was 1 by 80.
Yes.
Right? And then 2 is out of that box.
Yes.
Now there are 79 left.
Yes, only
2
79.
means number 2. 2 means not 2. 2.
Yes.
Second
round of sampling which we will be doing.
Yes.
So the second round would be out of 75 people we will be doing. So what?
79.
Yes, 79 it would be there. So one by one it would be reducing like this. So that is without replacement.
That is without replacement.
With replacement means...
No, coming to 1 minute. Coming to with replacement later on. Then what is the problem in, let me tell you, this is something what we do use mostly in our research work. What we generally do in our research work. So if you are selected, if you are the second person, right? If you are selected, then you will be out of that box because you are already selected. And we generally do in our research work, we generally do this, right? But then what is the problem behind this, doing this? The problem lies with that it is actually in contrary to the basic definition of randomization, because we started by saying that each element has an equal opportunity or independent chance of being selected. But here, without replacement, right? What happens? That one by one, this chance is getting reduced. Am I making sense here?
Yes, ma'am.
Right. So it is technically, it is following the literature. Technically, it is violating the concept of randomization. It is contrary to that. But then we need to go for the second one, that is a with replacement. What will happen in with replacement? Out of, we have to select 20 out of 80, and then we will select the first one, the first element to be included in the sample. Then the chance is 1 by 80. Then we will note down that what is his or her number who first got selected in the sample, and then we'll again put that thing back in the population. And then again we shuffle these things and random number generation can be done. Then we pick and choose randomly. Then only this randomness definition is maintained, keeping intact. Because for each and every element, the chance is, the probability is 1 by 80. Because when we are selecting one element in the sample from the population, we are giving it back. But then you can always ask me, then if the same element is getting selected twice, what do we need to do? The thing is that by chance, because it is random, so the chances of getting selected one element twice or more than twice, I mean more than once, is very less, right? If it is by chance, again it is by chance getting selected, then we will again do the drawing, this kind of random number generation, and then definitely next time would be something else. Am I clear here?
Yes, ma'am.
Right? So that is what the concept of with replacement. But I'm telling you again and again, we generally do in our social science research work this without replacement. So once it is getting selected, we'll keep it aside. That element will not go back to population.
Ma'am,
Right? Yes.
as you showed that random number picker, so in that this sampling without replacement was actually happening, because if
Yes.
suppose again the same number comes, suppose when you did it ran it first, so then it came as 77 and then different numbers came. So suppose before we have completed the 20 selections, if again 77 comes, we will again do the same
then we
thing.
will, yes, then
That will
again
be like, if we are using that random number picker, then it will be sampling without with replacement.
with replacement. Yes, right. So what we showed there, I think this is with replacement, right? And then by chance, because the same element to be again coming back for the selection of the sample is definitely very less probability. But if it is coming, so suppose 77 was the first one, and then after 11th shuffling, 77 again is coming, so we'll again generate one. Click on generate, and definitely next time 77 will not come. Maybe 78, I mean, be there. Maybe 78 will come, isn't it? That is actually with replacement. But in our day-to-day research work, especially in psychology or when we are dealing with primary data and all, so we generally go for this without replacement one. So once it is selected, it's done, right? Can I go ahead? Yes.
Yes, ma'am.
So the pros and cons are very simple. So pros are that it has simple random sampling. It's basically very simple. You don't need to think much and all. But the only the thing is that it helps the representative groups from the overall population. It allows the findings findings can be generalized, because you are technically you are addressing that entire population. So the population, all the 100 doctors are there, surgeons are there. From there, you are randomly selecting the representative, and they are the best representative because you are randomly selecting them. Okay. And the easiest way to do it, and I guess now onwards, this random number generation is going to be very easy to all of you and very interesting. So you will try it when you will do it in your research work. It offers equal chance of selection of people into this sample, and it also provides a lower chances of data errors. It's basically, it is not data errors, it is basically going to be a sampling error. Chances of sampling error would be very less just because of it is random. It's a complete randomness. Okay. The cons are, there are very serious cons over this. The cons can be that it requires sample size which is too large, because like when you are collecting data randomly, and in order to get this generalizability of the data, it should be large enough, because you are drawing it from a population. The population should be large, and then you have to select the sample size which is also large, because if you are selecting 2 people and trying to generalize something, it is not going to be the very ideal generalization, right? It doesn't provide any kind of guarantee. This is very important. It doesn't provide any guarantee that the data conclusion would be accurate. Why am I telling you? Why I have written these things? I will tell you a little later. Third one is also very important when it is a kind of widely dispersed population group. So there are many different subgroups there in the populations. We need to be very, very cautious. We cannot simply use this simple random sampling. Okay. And it is time consuming because you have to collect a large number of sample size, hence it is time consuming. So this first and third, last one is very easy. Second and third is a bit difficult. I'm telling you why, because sometimes in the when you are using simple random sampling, what maybe you are randomly drawing the samples, but then when there are different subgroups there in the sample, there in the population, then by chance, suppose there are subgroups like mentally retarded, suppose a special education school, right? So maybe a school, just a school, right? And you are collecting students randomly using this random number generation. Now in that school, there may be few mentally retarded, few students may be having learning disability, few may be autistic, few may be a Down syndrome, and few may be normal students. Now, if you are mixing, there are diverse population, right? Diverse groups in the population. And then when you are using this random number generation, maybe by chance you are putting them together, all this mental retarded, autistic, Down syndrome, etc., as well as with this normal children, mainstream children, you can call it. If you are putting them together and you are choosing them random using this random number generator, sometimes it may happen that you are choosing only those who are very much dominant in this particular population. Basically, this normal children would be dominant, right? Followed by this specially able children. So maybe you are drawing 20 students in the sample from that 100 students there in the school, and with the help of this random number generator, it may be possible that you are selecting mainly those normal students, normal children, and very few of those there in those categories like maybe dyslexic or special, maybe mentally retarded, MR, and learning disability, etc., etc. Then do you think that is going to be a generalizable to this entire, the conclusion is going to be accurate? Hello? Hello?
No, ma'am.
No.
It would not be correct.
Yes, that is what it is said, that it doesn't guarantee the data conclusion to be accurate. And when it is, especially in case of, doesn't work in case of the population has diverse or diverse groups or dispersed groups, right? Okay, now let's move on. It's another probability sampling method, that is systematic random sampling. Systematic random sampling, as you know that here what you need to do, you are, instead of, it is also based on this the concept of the random principle, principle of randomization. It is, instead of using these random numbers, here the researchers first tries to identify the skip interval in order to select the sample from the population. So what is a skip interval? Skip interval, this is the formula of skip interval. It is very simple. Don't go scared by this formula. Very simple. You all can do it. That is the number of elements in the population and divided by the required sample size. Here, the skip interval stands for K. Number of elements in the population, it is capital N, divided by the required sample size is small n. I guess it is clear now. Now, moving on, that is the continue with this systematic random sampling is that, for example, a researcher wants to select 100 people from the universe, from the population, that is 1,000. Now, if this is, I know that I have to select 100 elements from the population into my sample, and my population is 1,000. Then what would be my skip interval? Without looking here, just please calculate. That is 1,000 by 100. What it could be?
10.
10. So the skip interval is 10. And now, when this skip interval is selected, then the researcher is going to select one number randomly. That is, skip interval is 10. So one number randomly can be selected. Now you can use this random number generation table as well, or this particular software as well. You can use, that is 1 to 10, and then the number that first comes to in this random number, that is, suppose, for example, it is 5. So then the first sample would be 5th one. The 5th individual, it's not 5. I don't know, am I clear or not? But then it is no, I'm not saying the first sample would be 5, 6, 5, 15. It's not like that. I'm saying the 5th individual there in that population, he or she would be selected as a sample. Now, as this skip interval is 10, now every 10th one. So the 15th, 25th, 35th, 45th, so on and so forth. Am I clear?
Yes,
This is that position. This is not a number of that person. This is a position, right? Okay. The pros and cons of this systematic random sampling are, biggest advantage that you can see, it is very much convenient. Here, you no need to even, I said that it is, when you have this skip interval, you can use this random number generation for identifying that the first element, because 10 is a skip interval, but then first number that you need to select, 1 to something between 1 to 10, that you need to randomly select. Now you can simply pick and choose a number, or you can use even that simple random sampling, random number generator, but it's your wish, but it's not mandatorily that you have to go for this random number generation. So you can simply pick and choose. As a researcher, you have that right to do that. Okay. So this is very convenient. There isn't a need to number each and every element. So each and every element you no need to number. Like simple random sampling, you have to number 1 to 100, and then you have to you know, like you don't know which number, which positioned individual is coming. Here the once you have that first element, you can only pick and choose that first element plus that skip interval. So the first element is 5th, second would be 15th, third would be 25th, so on and so forth. Right? It reduces the risk of favoritism, but however, this same advantage was there in simple random sampling as well, and it is cost effective. So you don't need to work much. You don't need to use any random number generator every time. Maybe once you can use it, or if it's you as a researcher, you choose that I will go by the second, sample first. So second element in the population will be selected, and then 10 is the skip interval. So second one, 12th one, so on and so forth. Okay. The cons would be that it is creating some kind of fractional chance of getting selected, because if by chance, if you are biased, then if your favorite people there in 1 to 10, you can select that first individual based on your favoritism. It's not always possible. It's not always the cons of this, but there may be a chance of that way of saying. If researcher is unbiased, then he will definitely be using some random number generator while choosing the first element, and then so on and so forth based on the skip interval. So this is the few cons of this systematic random sampling. Is it clear?
Yes, ma'am.
Okay. Now next, stratified random sampling. Stratified random sampling is, what do you mean by the word stratification? Any idea? I guess you have the idea. What is the meaning of stratification? What is the meaning of stratification?
Ma'am, it means the stratas or the levels, different levels.
That is true. So that is it means stratification is divide, like division.
Division.
Simple word stratification means it is division. Now division of what? Division of what? What? This is the question. Division of the target population.
Yeah.
Target population, not the entire thing, but then target population. So if it is a division, for example, my target population is academicians, right? Okay. University academicians, university faculty members. That is my target population. Now I can subcategorize them, I can divide them, or I can categorize them, or can stratify them into different, based on my understanding, I can stratify them into different levels. What are those levels? Maybe assistant professors, associate professors, professors emeritus. Suppose 4 categories, subcategories, right?
Yes, ma'am.
Okay. Now these 4 categories are independent to each other. You cannot simply say that, okay, the person is an assistant professor, is also an associate professor. It's not. It's ridiculous, isn't it? Isn't it?
Yes,
right?
ma'am.
So
The
they are non-overlapping. Yes.
Yeah,
so
the
they are
categories will be independent from each other.
Correct. Right.
And among
Okay.
that, we will
Yes, and when you add up those things, it will actually represent the entire population. So when you add up those things, it will represent the entire population, right? So when you add up this assistant, associate professors, professors emeritus, it will give the the complete population. So this is what it is written here. So N1, suppose N1 is assistant, N2 is associate. There are other Ns, and NK would be the professor emeritus, right? So N1, N2, N3, N4, right? Equals to capital N. That is a university academicians, right? So each subpopulations, they are known as strata. So assistant professor is a strata. There are many people under this assistant professors. There are many people under this associate, so on and so forth. All the strata, they are independent. But within the strata, within a particular stratum is a singular and strata is plural. So keep it in mind when you write down, write it accordingly. Strata is a plural, stratum is a singular. Okay. So within each stratum, they are homogeneous. All are assistant professors. All in that stratum, associate professors, all are associate professors, right? Having a similar type of characteristics, similar type of experiences. Clear? This is another example I have given here. So you can read the definition as an example and you can, understand it. So in a household, a village, selected village, so there are households, different types of people, categories of households. Scheduled castes, scheduled tribes, OBCs, others, general categories, minority, etc., etc. So when you add up, it will give you the entire population, village population. Okay. So now what do we do in this stratified random sampling? This method helps you in conducting and managing a large scale of data. And when it is there are many subgroups. So in India, as I told you earlier, in India, there are different states. There, the states, within states, the people are, the population within states, even their population is homogeneous. So if you go to northeastern part of India, so they are homogeneous. 7 sister states, they're homogeneous, but they're different from us. We are different from them. So if you have this northeastern part as a one stratum, eastern part, what we are falling into this another stratum, western part, and the southern part and the northern part, right? So there could be different stratum, and within the stratum, people would be homogeneous. Characteristics would be homogeneous. Okay, done. Okay. Yeah. Now what happens? Yeah. Any queries?
No, ma'am.
Okay. So now this is the basic concept of stratified random sampling. Now to move on, there are 2 types of stratified random sampling. Okay. So one is a proportionate stratified random sampling. Proportionate stratified random sampling, I said. Proportionate stratified samples. Here, first, it is stratified random sampling. So it is dividing the population into different strata. Right? There are different strata. Right? And then from each one of this stratum, they are selecting people based on the proportion there in the population. Based on the IDP, based from each and every stratum, first proportionate stratified random sampling is first dividing the population into different strata. Suppose dividing the population, if you get this example, if you take this example, then it's dividing the village population into different strata. How many strata are there? SC, ST, OBCs, others, maybe general categories, and the minority. Okay. Now, the proportionate, as it is proportionate, then from each one of this stratum, right, then the researcher will select based on the percentage of that particular population coming under a particular stratum. So, for example, SC people are 10%. They're in that village population. ST people 5%. OBC is 45%. Others 30%, and minorities 10%. So when a village sample is being taken, then out of 100, suppose 100 would be my sample, and I know this percentages 10%, 5%, 45%, 30%, and another 10% from each one of this stratum, then in this 100 sample, SC, how many SCs would be there? Tell me. How many SCs would be there?
Ma'am, in a sample of 100?
10.
Yes.
10.
These are the percentages. These are the percentages which is actually there in the population, village population. Tell me if it is clear or not. So these are the percentages. The researcher has stratified the village population into this 1, 2, 3, 4, and 5. Sorry, 5 strata. Then these are the percentages. Now he needs to select 100 sample out of this village population. Then how many samples would be there in SC out of 100?
Would be in the similar proportion, 10% of 100. So,
10.
yes, ma'am.
Yes, 10. SC would be 10. ST would be how many?
5.
5. Now you start adding up as well, whether it comes to 100 or not. OBCs would be how many?
What?
In this 100? 45. Others would be?
30.
Right. And minority would be 10. Huwa na? 100.
40, 45, 85, 90. Yes, ma'am.
Done. So this is how it is. Right? Now, the problem I am coming later on. Okay, let me just tell you. The problem is that this, otherwise this part is good enough to go with this when we are dealing with a normal thing. So SCs, STs, OBCs, caste differences or caste categorizations are the normal thing, right? So you can go ahead with that proportionate stratified random sampling. But when suppose you are dealing with a critical cancer patient, right? And you are dealing with a particular population where there is only, you are dealing with a cancer population, but a typical cancer, a very rare category of cancer. That is not very usual, obviously. That is going to be max 1%. Now, if you are using this proportionate one, suppose the population of 100, it is, the population is 50%, right? And sorry, the population is 50, total population is 50. The cancer patient population is 50. Okay. And out of which there is only 1% which are representing a typical cancer categories, particular type of cancer. Now, if you are trying to use this proportionate one, and you are studying that the basic features or the remedy of that particular type of cancer patient, and if you are selecting this based on this proportionate stratified random sampling, then you probably would be committing certain mistakes. Any idea why? Any idea why?
Maybe because of the lesser population, the true representation will not be there.
True representation will not be there when you are dealing with a very specific and very rare thing, right? A rare type of heart disease, very rare. But you want to do certain, like invent certain kind of medicine for them, right? And you are using, you thought that, okay, let me go proportionate, using proportionate random sampling. Then a very small percentage of that would be included in your sample, and the large percentage would be included, which is not falling under that proportionate, sorry, not falling into that rare category. But you are trying to do something with the rare category. Then what will you do? You have to go for disproportionate stratified random sampling, because I'm trying to establish this point that disproportionate stratified random sampling, do not think by the name, do not go by the name. Looks are always deceptive. It is disproportionate. Its name is disproportionate, but it is actually useful when you are, working with a very specialized or a very rare type of thing. Am I making sense?
Yes, ma'am.
Right. Okay. So that is the advantage of disproportionate stratified random sampling. Okay. So the basic pros and cons of stratified random sampling, including this, that is a very specific disadvantage I told you for this proportionate, and specific advantage of proportionate. But sometimes when you are, like when in case of this caste example, if you are using that disproportionate would be not applicable, because maybe if you are randomly selected them, even after categorizing the population into different caste, then maybe by chance those who are there in the larger dominant categories, they would be selected more than others. Here, proportionate would be more applicable. So we have to keep it in mind that which one is applicable when. The overall pros and cons of this stratified random sampling is, that is the accurate reflecting the population studied, can deal with more diverse data, more manageable. Sample bias is very less, because sample bias is more or less less in case of this random, the probability sampling, because you are end of the day, you are using random samples, right? So even if you are stratifying them into different categories or different strata, from this each one of these strata, you are choosing them randomly. So this reduces the error of sampling error rather. And cons are, however, this one requires much more planning, because you need to know what are the different dominant groups there in this population. And also you need to know that whether you need to go for proportionate or you need to go for disproportionate. This should be wisely selected. Otherwise, your sampling would be technique will go wrong. And it is time consuming, because first you need to do this stratification, and then from each one of this stratum you need to randomly select them. So it is going to be a time consuming and very bit tedious. But if you are a very confident and a very expert in using these things, this cons will never be cons to you. Okay. Now we'll move on to the next segment, which is a cluster sampling, which is apparently you will find similar to stratified random sampling, but it is not, I'm telling you. And many of you may not be aware of these things, few of you maybe, but I would like to tell you the basic difference between these two, because these two are sometimes a bit confusing. People do think they are similar, or rather they are same. They are not. There's a huge difference. So let me just first tell you, I guess you can see this figure. What is this figure? Because it is in cluster sampling. So the entire population is first divided into different clusters. So here suppose a particular colony, or maybe a particular place. Maybe you can take the example of India, as I gave you the example. right? So India can be divided into different clusters. Suppose these are the different clusters of India based on their, like the geographic information. A, B. Tell me how many of them? A, B, C, D, E, F, A, B, C, D, E, F, G, H, I, J, K. So there are 11 blocks. You can also write down that there are 11 states of India, right? Now, what we need to do from this, when we are using this cluster sampling, we are treating this each block as a cluster. So 11 blocks means 11 cluster. Now, we will select the clusters randomly. That means we will select 2 blocks. For example, 2 can be varied. So if you want to select 3 blocks out of 11, you can. It is up to you, your availability of the data, your objective, how many blocks you need to collect, or you need to select rather. So you select 2 blocks out of 11 blocks, for example. That you can select randomly. But then when you have chosen 2 blocks, all the elements coming under these 2 blocks, you have to collect information from them. I repeat, here the difference between cluster and the stratified. In cluster sampling, we are saying that we first divide the entire population into different blocks or different clusters based on your own understanding or your own other characteristics. Now we have divided this entire population into 11 clusters, and we are selecting, for example, 2 blocks out of this 11 blocks at random. Now 2 blocks selected. Now we need to collect information from all the elements coming under these 2 blocks. Means here we need to collect information from all the families who are residing in these 2 blocks. Suppose, for example, there are 11 blocks. Randomly, we are selecting A and I. So all the families who are residing in A will be, data would be collected from them. Same thing applies to I. So where is the difference between, now can you see, because I have repeated it several times. So can you see the difference between this cluster and stratified sampling?
Ma'am, in stratified sampling, we are dividing into different stratas.
Strata.
Now, out of these stratas, we will choose randomly and pick.
Good.
Whereas in cluster sampling, we will be choosing all the people from those blocks.
Yes. So to be very specific, you are right. That means, I just repeat, you are absolutely correct. In stratified random sampling, we are first dividing the population into different strata. So maybe 4 different strata. For example, A, B, C, and D. Now, all the strata, from all the strata, we will consider all the strata. And then the elements which are coming under all of this strata, suppose the elements which are coming in strata 1, strata A, we will select them randomly. Maybe there are 50 elements coming in strata A, so we will select randomly. Either it is proportionately or it is disproportionately. Now we'll go to the next stratum, that is stratum B. Then we will select the elements from that particular stratum. We will select based on proportionate or disproportionate. Then go to section stratum C. so on and so forth. But here we have categorized the population into different clusters. Clusters, first we are randomly selecting the clusters. Now, 2 clusters, there are suppose 4 clusters. So clusters are the blocks. They are clusters. Now, out of these 4 clusters, 50% would be selected. So we have to select 2. Then cluster A is getting selected and cluster C getting selected. So then we will simply, remove B and D, which are not randomly selected for the final sampling. Selection done with A and C. Then all the elements which are coming in A, we have to collect data. We will not do any kind of selection. Everything coming under strata or cluster A would be studied. Everything coming under cluster C would be studied. This is what the cluster sampling. That is why stratification is done to make the strata homogeneous within. So all the assistant professors, they are homogeneous with respect to their qualifications, experiences, etc., etc. They are different from other strata. So assistant professors different from associate from professors, and so on and so forth. Clusters, on the other hand, should be heterogeneous. Clusters would be heterogeneous. A, B, C, and D would be heterogeneous within, because in cluster A, you will find, suppose in cluster A, West Bengal. So you will find different caste. So cluster A is West Bengal. Cluster B is Orissa. But cluster A and cluster A, within the cluster even, there are heterogeneous population, and you are considering all. Suppose Orissa and Maharashtra getting selected, right? But where is the similarity? Orissa and Maharashtra both are coming in India. Both are different states of India. Am I making sense here? Is it clear? I guess it is.
Yes, ma'am.
Right? Okay. Now the pros and cons of this cluster sampling. Cluster sampling is much more feasible, and it requires choosing selected clusters at random. So the clusters are getting selected at random, than the selecting everything from this entire population. So it is more representative. So when you are selecting, because India is a diversely populated country, so when you are using this simple random sampling, maybe by chance you are, maybe the bigger states getting more samples, elements into the samples vis-a-vis the smaller states. So you need to, when you are dealing with this geographical, information and all, you need to do cluster sampling, because India is a diversely populated or widely populated. Okay. And it saves time and money, because once it is clusters are getting selected, you don't need to think of those clusters who are not being selected. You only need to work with those clusters who are getting selected. But the problem lies there only. That is the advantage, and that is, if not efficiently used, it is going to be a cons of this cluster, the cons of this sampling. The cons is that it is biased. So maybe we belong to West Bengal, and you are a researcher of West Bengal, so you select West Bengal. Somehow we like West Bengal. Pune, a researcher will select Maharashtra. Somebody from, like maybe Odia will select Orissa. Right? It's somebody from a southern part of India who will go for Andhra Pradesh, etc. It may be. All the cons, there are chances. It's not that inevitably somebody is committing this error, but if there is a chance of the biased in this thing, and if that is a biased one, then it is going to be an improper selection of the clusters, and the result would be definitely not very generalizable. Okay. So with this is the all about this probability sampling. I will rather request all of you just to write just one of small paragraph on what you have few slides so far. So what you have learned so far. So maybe I will give you 5 minutes time. Now it is 9:26, so maybe 9:30 or maybe 9:31. We can have this broad sketch of what we have learned. So can you do it right now? I'm not asking you to write any answer. I'm asking you to simply write the topics which we have covered so far, so that I can understand that you have understood a little bit. Yes, can we do this? So you will have 5 minutes time and we can quickly do this. Hello? Hello?
Yes, ma'am.
Yes, so just 5 minutes time, just try to write down the topics which we have covered. So time starts now. Okay.
I think your time is over, no?
Yes. ठीक है.
31.
Yes, if they need 1 more minute extra, it's okay, no problem. Let them write or let them understand the thing, because things are not that easy, which we find it right now, but maybe a bit difficult to them. So is it written by few of you?
No, I am telling that is a student's assignment time over.
Okay. Have you, all of you have written? If you have written, if you can tell us.
So there also the sign to
Yes. Who wants to say what are those topics which we have covered so far?
Okay, ma'am. We initially we started with population and sample, and then we proceeded with
Yes.
there are different types of sampling in which
Right. Yes, you are not audible.
side random sampling, and with that proportionate, disproportionate under that, and then cluster sampling, and all of its pros and cons also.
Right. Now, can you quickly tell me or anyone what is the where is the difference? Because other two are very easy to distinguish, simple and that systematic random sampling. Where is the difference between this cluster sampling and the stratified random sampling?
As we just now discussed, that in cluster sampling, when we take the each clusters have heterogeneity, which is not there in the different when we talk about the
In cluster sampling, we are randomly selecting the clusters, dividing the population into different clusters, randomly selecting clusters, and then studying all the elements there in
under that cluster.
randomly selected clusters, right?
Yeah.
And in stratified random sampling, we are dividing the population based on certain criteria. So maybe based on the education of the experience and all of academician, and that is assistant, associate, etc. So that is the different strata first divided, and from each one of these strata, we are randomly selecting based on proportionate or disproportionate. We are randomly selected few elements and including them in the sample. Okay. Right. So that is the basic difference, right? So you will keep it in mind so that when you write down, do your assignment, you do it correctly. Non-probability sampling is, yeah. So non-probability sampling method, we all know by now that these are the sampling methods which are also useful and widely used in social science. But the only thing is that in non-probability, as its name implies, that we are not using this random, random principle while choosing the elements there in the population for including there in the sample. So we are choosing them based on certain predetermined characteristics, or maybe the judgment or the purpose of that particular research work, right? So in this case, the first one, which is very much widely used, that is a quota sampling procedure. When quota sampling is, you will find the similar to this stratified random sampling, but it is similar. But the difference is that because in quota sampling also the researcher is dividing the subgroups, dividing the population into different subgroups or different divisions or different strata. But the only thing is that while selecting the elements from each one of these strata, elements to be included in the sample from each one of these strata, that selection, like stratified random sampling, that is a random selection. Here, the researcher is selecting based on certain like certain kind of availability of them, or based on certain purpose, or based on certain other predefined parameters. So here, this is suppose the kind of the example. Suppose the researcher is trying to see the impact of child labor, impact of so in the explore the the prevalence of child labor in India. So what do you think that maybe the child labor, the entire population, the child labor, all those children under this, they are included in this, that they are included in the population. Children who are victim of this child labor, they are included in the population. Now the thing is that that for that particular population, the victims of child labor, then that population is divided based on, suppose, based on the socioeconomic level, or based on the religion, based on the maybe the gender. So when you see that, suppose child labor divided based on the gender, right? Then you will find that maybe more, and then he selects even those, he needs to select only those who are there who are the victim of child labor, and selecting maybe, and coming to this conclusion that maybe the male, the child labor mostly are boys, not girls, right? So here you cannot go for any kind of random sampling. Rather, you are selecting only those who are the victim of child labor, not getting any deprived of education, etc., etc. And they are definitely from very lower socioeconomic status. So you will definitely not be, studying any children from higher socioeconomic status. Do you think that will be very wise sampling technique? Then definitely nobody from the higher socioeconomic status will be the victim of child labor. Am I making sense here? Hello? So that means from each one of this subset, the participants are not chosen randomly, because it's a very specialized thing that you are going to study. And, like it is based on the convenience. Maybe few of them. So you are contacting your neighborhood tea stall where there are 2 child laborers, and both of them you found that male, boy child labor. You will not find much who are there who are the girl child labor, except the particular profession. You won't find that. That is what because this is not a very randomly cannot be chosen. And that is why it is known as non-probability sampling, and it is coming under quota sampling. So the quota sampling is something, which is non-randomness is included, but it is easily can be, can be selected, very conveniently can be selected. But on the other hand, the major cons would be the non-randomness. Non-randomness. Okay, so it is based on your assumption or your preference, your judgment. Next comes, as we are saying so much on this judgmental and being having certain purpose. So the next one would be purposive or judgmental sampling. So purposive sampling, known as judgmental or sometimes known as subjective sampling as well. It is again a kind of researcher's judgment. Researcher's judgment that whom to select in that particular sample or in that particular research design. I mean, in that sampling, in the sample from the population, whom to select. So as I gave you an example that there is another example given here, that research analyzing the the impact of maybe the personal tragedy of those family members, maybe having certain, experiencing certain tragic accidents or something like this. If you are simply analyzing them, their mental state or state of mind, then definitely you will not be choosing randomly those who do not have that much of family personal tragedy or etc. like this. So you will be selecting those people only like having certain personal tragedy. So like maybe people who experience tsunami, you want to get their viewpoint, like how did they feel, how still they're facing, like the that particular that natural disaster haunts them tilted. So if you are trying to like kind of study them, so it's not of you studying us who are not the victim of tsunami. So I guess this is very much like suitable over there. So this is this kind of graphical, diagrammatical representation of purposive sampling, right? So from the population, only this certain category is like the black, that people they're in the black color. It's nothing to do with the skin color. I just trying to say that they are the right person to be included in the samples, hence they got selected as a sample. Advantages are many. It is quickly you can do it. You know who are your target samples, so you choose them on that population, and it is cost effective. You don't need to do a lot of people, select a lot of people, and it is not going to be like a very ineffective. Rather, it is very effective. Mostly effective is anthropological situations where this discovery is from certain intuitive approach, right? So this few people having certain kind of common characteristics. So people belonging to, like people falling in the same category, maybe having certain similar type of characteristics. So this is something which is very effective in some purposive sampling is very effective. Disadvantage could be that is again the main disadvantage, as I said, it is non-randomness, inability to generalize, and the vulnerability that the researcher can be biased mainly. So the sampling error may go very high. Maximum variation sampling is something that is often referred as a maximum diversity sampling, and it is used when a researcher attempts to collect data from the widest range of perspectives possible about a certain topic. So it is something like when a researcher is trying to understand the public opinion about a particular television show. So suppose, even if it's not a television show, like public opinion of a particular movie, right? Recently, you have this, like we all almost watched Jawan movie. So that if you want a public review on movie Jawan, right? So you need to first, get the viewpoints of those who are very young and they watch Jawan movies, they are the fan of Shah Rukh Khan, etc., etc. Then you have another category is that very young but not a fan of Shah Rukh Khan, but then like this theme of Jawan movie. Then another category would be not a very young but middle-aged, but then they are a fan of Shah Rukh Khan and like the theme of Jawan movie. Then another group would be a very, like a bit older people, not a fan of Shah Rukh Khan, but then was this like the theme of Jawan movie. So there are maybe different categories, but then this category is only applicable to those who watch the Jawan movies. It's not that if who did not watch it, they are not applicable. They are not at all suitable for this particular sample. So the groups, you have to understand which group to study, right? Advantage as similar to other probability sampling. Advantages are very quickly you can get the samples, and you are very like focused here, that you are going to review or interview those people who watch Jawan movies. Now their age could be different, very young categories, very whether middle aged or maybe old categories. And another categorization could be like young categories, fan of Shah Rukh Khan, not a fan of Shah Rukh Khan, fan of the theme. Another old middle categories, again fan of Shah Rukh Khan, not a fan of Shah Rukh Khan, maybe like the thing. So on and so forth. This is a very advantageous, and very quickly you can do it, and you are simply studying those who are relevant in this particular sampling method. And then disadvantage similar to other non-probability sampling methods, that non-randomness, and only you cannot generalize it. So you cannot generalize the same kind of review for any other movie. You cannot say that, okay, any kind of Shah Rukh Khan's movie, this is the review. No, this is the only for Jawan, very particular movie specific, right? So this is something which is a biggest rather disadvantage. Okay, the expert one, in case the expert sampling, your respondents, in case of expert sampling, your respondents must be known as expert in the field of interest to you. Suppose here, as a researcher, you want to see the effectiveness of COVID-19 vaccination. So if you are asking me, do you think am I the person who will be able to tell you the vaccination, their effectiveness? Am I eligible for that?
Maybe not.
Not at all, not maybe. Like you be very straightforward. I'm not, because I know the only one which I have taken. I don't know anything more than that, right? Then you as a researcher, you have to select those people, those respondents who are the expert in that field. So maybe the doctors, especially not even the doctors, who are the scientists who invented this. They know better than any one of us what are the pros and cons of each one of this vaccination, right? So you need to ask those who are expert in this, right? And another thing which is similar but not same, I guess, that is yeah. So another, it has a certain similarity, because here also you are using your judgment, but the only difference between should not be confused with judgmental sampling, because in judgmental sampling, in case of judgmental sampling, it is researcher's judgment as to the ability of that, the researcher is expert enough. So he is making a judgment that, okay, I as a researcher, I know that only I am judging it that and my purpose is to know that the effectiveness of this, or the pros and cons of this present financial year budget. So I, as a researcher, I know that I need to, this is my judgment, that I need to select those people who are very much effective in giving me data. Here, in case of expert sampling, your respondents must be very much expert, known expert in the field that you are, it interests you. So there is a difference. So one case, researcher is making a judgment. Another case is that your respondent should be expert enough, so that even if you, don't like one doctor or one scientist, but as that person has invented that Covaxin, you have to go and talk to that person. So you do not have any option, right? So this is the basic difference between this judgmental purposive and judgmental or purposive and expert sampling, right? Next is homogeneous sampling. It's the kind of process of selecting a small homogeneous group of subjects or a unit for the examination or for the analysis and collecting data from them. So it could be like if you are trying to, understand the kind of social interaction of those autistic children, right? So then you go and talk to those autistic children only and try to understand their social interaction pattern. If you want to know that mental state of a person who is an asset victim, so you definitely not going to address the entire population, right? I mean, you're not going to select people from the entire population. Rather, you simply go to a particular, a segment who are the asset victims, right? So this is something is homogeneous sampling. A typical case sampling, something related to homogeneous as well as rare group sampling, which is extreme or deviant sampling. Similar, they are all similar. So it could be a very typical, atypical case or extreme or deviant case. So maybe you are studying some, the delinquents, a group of delinquents. So there you can study the delinquents, that particular group, which is a typical group or a very extreme group or a deviant group. You are studying them, you are studying their, the family environment, and you found that family environment is playing a role and playing a critical role in making a person a delinquent. So that can be, you can use typical case sampling. Extreme and deviant cases. Extreme and deviant cases, you can, similar to what is there in typical case sampling, similar, obviously. And here also you can maybe some a particular, maybe rape victims, right? If it's a kind of extreme case, right? Or maybe the serial killers, right? So they are the deviant cases. So if you are studying that the personality type of serial killers, using a particular type of killing technique, or like there was a movie I found, I'm sorry, I watched it. You can also watch it. You will find this extreme deviant case sampling. That is the Gumnam movie. Gumnam is not that Purana wala, not that ancient type, ancient movie. This is very, like not very new, but this is not that ancient one. So if you search in the YouTube, you will find this Gumnam movie that is actually working on a, like on a serial killer concept and killing using a certain strategy. So like leaving the, the head of a doll along with this dead body. That is, like one example of extreme deviant cases. Critical case, again similar, because all these things, it's separately there in your syllabus. So I tried to incorporate all of them. Otherwise, they are all similar, but it is very critical case, as I told you, that a critical cancer patient, and suppose there are only one or two cancer patient there in India. So you go and pick up those patients, very small number, but you are trying to, invent something, some cancer, maybe some vaccination. Then you go and select very small number of people from there suffering from that particular cancer, along with other, comorbidities, etc., etc. So you go for this critical case sampling. Okay, and which was not there in your syllabus, but yeah, so I have added two more, because these two are something which is, another type of non-probability sampling, not added in your syllabus, but I thought of adding it. It may help you in future. So one is convenience/accidental sampling. Another is snowball sampling. So these are something different what we discussed so far. So like it is like convenience based on the researcher's convenience. When researcher is trying to conduct certain, trying to select people based on his or her convenience, trying to select few people in the sample and doing his research work, then this is coming under convenience sampling. So suppose I am trying to find out that the education system of private universities with special reference to AUK, Amit University Kolkata, the place I do belong to. So it is convenient for me. No? I go every day, means Monday to Friday, and it is convenient for me to know the entire thing. I can talk to those people who are there in the management, ask them, they will give me the actual data rather than if someone of you going to MIT and collecting data, that would not be much more, authentic when I am collecting it. So that is a convenience, based on the convenience. Another is very important, and we do use in many a times, and especially we used there in this during COVID time when we were running off online completely. So we use this snowball sampling. That is, that researcher is actually encouraging the respondent. The researcher is selecting one respondent, collecting one sample, collecting data from them, and then encouraging the respondent to give the name of other acquaintances so that they also can give the data. And this way the researcher is actually creating a kind of network or a chain. And that is this is sometimes we do use, and we used widely during COVID. If you remember, you must have prepared one Google form and you send it to one of your friends or maybe a group of your friends and ask your friends that send it to those whom you know. I guess you have used it, right? Many of you, isn't it? So this is widely used in social science, right? So this is snowball sampling. Anyone is hearing me till now?
Yes,
ma'am.
ma'am.
Okay. Right. So this is end of the non-probability sampling. These are things I have already mentioned, specific to the particular specific to a sampling technique. So these are very common here. These are common advantages and disadvantages. So the basic common advantage of non-probability is that it is conducive, it is very much easy, faster, cost effective, and very quickly you can do it. But the first and foremost is that, as I have been telling you since very beginning, that non-randomness is the main disadvantage. It is creating a lot of sampling bias or sampling personal bias, sampling error. But do not think, this is just the last thing I'm going to tell you, that do not think that non-probability cannot be used. As I tried my best to give you the examples to relate to those situations when non-probability sampling method is the only appropriate way of collecting or way of choosing samples from the population. Probability sampling will not work there. So you as a researcher wisely need to think through and understand and keep it in mind all the different conditions, and you have to select the sampling technique, sampling method wisely, so that your rest of the research process or procedure will be a correct one. So that's it from my end. And I would rather request you all that when you write down a critical discussion, if at all, this is the question for your assignment. So any kind of critical discussion, first of all, read the very small caselet and try to understand what sampling method can be used. And when you are writing down this pros and cons, so you write down very clearly that these are the pros following at the pros of this particular sampling, following at the cons of this particular sampling. And if there is any kind of the layout is being asked, so try to give a very schematic diagram, try to give some hypothetical example which will go with that particular sampling which you have you are going to write down your assignment, but then try to make a kind of diagram, schematic diagram, so that it is easier for us to understand and for you also easier to understand. I hope with this, I hope you all have understood what I have tried to say. If you have anything, you can ask me, or it's over to sir.
Thank you, Rita. You have covered very nicely. Because most of the people, they are thinking that is sample size is important. But sampling is very, very important. Sample size, not sampling, is very important. And you have covered both the probability sampling and the non-probability sampling. I think students have understood and students cooperated, participated. Therefore, I am thankful to the students. So, dear students, do you have any question? Anjali, Varsha, Shati, Monalisa?
Sir, I have question, but I will discuss afterward with you, ma'am. It's already late, so I'll discuss.
Okay.
I want you can give me that time when you're free. Then I'll discuss, or I'll message it to you, ma'am. I have many things to ask to you.
Okay, you then message there in the group. Okay,
Yes, ma'am.
that others also can get the clarification of this.
Yes, ma'am.
So now I am requesting Farah, please you give the vote of thanks.
Okay, sir. Hello, ma'am. On behalf of the entire class, we want to express our heartfelt gratitude for your outstanding teaching of experiment methods and sampling. Your interactive sessions, engaging teaching style, and well thought out assignments have made the learning experience of students truly exceptional. Your willingness to guide them through these complex topics have not gone unnoticed. You have made a significant impact on their academic journey, and we are grateful for the knowledge and skills you have imparted to them. Thank you, ma'am. Thank you, ma'am, once again.
Thank you. First of all, thank you, sir, for giving me this opportunity. And thanks to all the members, and special thank goes to Farah ma'am, because she has really helped me as and when I don't need any kind of help from her. And thanks to all the participants, and special thanks and belong to sir for giving me an opportunity. So thank you very much, and good night to all of you.
Okay, good night.
Thank you.
Thank you, Rita. Hope in future we will find you again.
That will be my pleasure, sir.
Thank you.